A strong X-class solar flare erupts from the sun. Extreme ultraviolet flash image by NASA given to us. Blackout map shows North America, South America, the Atlantic, Greenland, Iceland, and Africa, Europe, Eastern Europe, Western Europe has been affected. According to space weather, X-class solar flare, mixed up sunspot AR 3006, exploded May 10th and is coming into us now, producing an intense X 1.5 class solar flare. NASA Solar Dynamics Observatory recorded the extreme ultraviolet flash. Radiation from the flare ionized the top of Earth's atmosphere, causing a shortwave radio blackout around the Atlantic. And we have the blackout map here. Radio transmissions at frequencies below 30 megahertz were attenuated for more than an hour after the flare. Since the flare occurred, a mishmash of CMEs has billowed away from the sun's southern hemisphere. It's unclear if these CMEs are related to the X flare or instead some other lesser explosions that happened at almost the same time. There was a filament eruption to the right of the X flare at C4 class solar flare in a different sunspot to the left. NOAA analysts are busy unraveling these events using computer models to determine if one of the CMEs might hit Earth. So we have to stay tuned for this. So they're incoming. So what is an X 1.5 class flare? The largest explosions in the solar system get rewarded with fitting science fiction name X-class, made visible to us by sun-observing satellites. These solar flares are awesome to watch. Loops of solar material called plasma leap off the sun's surface and expand to 10 times the size of our Earth. The biggest flares can produce as much energy as a billion hydrogen bombs. Scientists categorize solar flares according to strength, the smallest being A-class at near background solar levels, followed by B, C, M, and X. Similar to the Richter scale for earthquakes, each letter represents tenfold increase in energy output. So an X is 10 times that of an M and 100 times the C. Within each letter class, there is a finer scale from 1 to 9. Although X is the last letter, there are flares more than 10 times the power of X1. So X-class flares can go higher than 9. As the sun approaches the peak of its 11-year cycle, expect more activity, and we are coming into a solar maximum. So we have almost every few days we have geomagnetic storms coming at us. So this is the extreme flash of the X flare on the sun, and they're keeping an eye as to what that means for us here. NASA said solar flares are powerful bursts of radiation. Harmful radiation from a flare cannot pass through Earth's atmosphere to physically affect humans on the ground, but when intense enough, they can disturb the atmosphere in the layer where GPS and communication signals travel. Yesterday's solar spectacle, peaked at 4:35 p.m. BST, released an extreme ultraviolet flash, has been classified by X 1.5 class flare by NASA. It originated from sunspot AR 3006. The flare released radiation that ionized the top of Earth's atmosphere, causing the blackout in the shortwave radio band around the Atlantic. Solar flares are triggered by processes called magnetic reconnection, in which the geometry of the magnetic field in the sun's plasma is altered. And as the magnetic field lines break and reconnect, they release some of their stored energy to form in the form of heat and kinetic energy. Now, astronomers began numbering the solar cycles in 1775, which is when extensive motoring of solar activity first began. We're now presently in solar cycle 25, and it has yet to reach its peak, meaning that increased levels of solar activity could be expected over the next couple of years until the pole flips in late 2024-25. Energy can be released from the sun in both the form of solar flares, sudden flashes of radiation, so-called coronal mass ejections or CMEs. The latter, on the most powerful forms of solar storms, manifest as a belched out cloud of charged particles and electromagnetic fluctuations. If sufficiently large CMEs have the potential to wreak havoc on the Earth, inducing fluctuations in the power grid, disrupting high-frequency radio signals, interfering with satellite operations in low Earth orbit. According to space weather, the mishmash of the CMEs left the Sun's southern hemisphere after the flare, although it's unclear if the phenomena are related. Two other events happened to the Sun at the same time that could have been connected to the CME. As we said, the filament to the right of the X class, the other C4 class flare to the right, and the U.S. National Oceanic and Atmospheric Administration, NOAA, are working to determine if any of these CMEs are likely to hit our Earth. So we'll know soon enough. The most severe geomagnetic storm on record, that was what was called the Carrington event. It occurred in the wake of a CME in September 1859. The Carrington event affected telegraph systems across both Europe and North America, as well as a recently laid transatlantic link that connected the North America with Europe. Currents generated in cables by the space weather event reportedly caused telegraph pylons to spark, operators to receive electric shocks, and some lines to fall and fail completely. Other lines, meanwhile, were found to still operate even once their power had been cut off. So strong were the electric currents induced by that storm. Fortunately, we're most unlikely to experience a space weather episode on the scale of the Carrington event in the present solar cycle, which is relatively weak according to astronomers and scientists. This is by Space Weather and Ian Randall and Express UK. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.